So usually I've done this talk before, and I had 45 minutes there, and I went over. So now I've got to do it in half an hour. I tend to speak fast anyway, and we're really going to sprint through it. So if we don't have that time for that many questions, you come chat to me afterwards. Cool. So I originally said this is going to be machine learning in real life, but essentially it's the less fun part. It's the part no one bothers to talk about because it's not the shiny algorithms and the shiny things. It's machine learning plumbing. We're plumbers. I am a plumber, a machine learning plumber by day, researcher by night. So I work at a company called Retro Rabbit. We build software, we do machine learning things, we do AR, whatever you want, really. Lots of fintech, lots of whatevs. I work, in particular, we're working with a startup called Kaleido. They require a lot of NLP stuff, which is very cool. So I largely work in NLP. And in my free time, like I said, I do research in machine translation for African languages. So if this is something you're interested in, come chat. We'd love to collaborate. This is actually what I'm famous for, was Twitter, as someone made very clear this morning. And it's like a whole, what's the little thing? Ooh, that wasn't meant to happen. I was meant to press a button. Oh, this has gone very wrong. Clearly not famous for using clickers. But something like, I got retweeted 12,000 times for literally the dumbest tweet I've ever written in my life. Disclaimer, background is in deep learning for NLP with kind of medium-sized data. I think it's very different if you're actually looking at so-called big data. I'm yet to see any big data. I know there are people in the room who have very big data. I don't know what that is. I haven't seen it. Also, I like to shove as much content as possible into these things, so I'm sorry if I go through it very fast. So machine learning is a very pretty picture, right? Prettiest ML picture you're going to see here. There's bunnies involved. It's ridiculous. But you get some data in, you get a model, you get knowledge out. We know all that. And what's really cool is you get all these people. If you want to learn machine learning, if you want to do models, you can basically, just spring up some notebook somewhere, download some things, blah, blah, you have a model, it'll probably work. And if that isn't it to you, you can just go, oh wait, there are all these other tools, they look great. I can probably ask one of the cloud providers to go do it. And what's great about this is, we've got a whole bunch of algorithms available. The research is fast and it's very open, so everyone's always open sourcing everything, it's lovely. Kind of hard to keep up, that's a problem. We've got help online, and there's kind of endless examples, so anything you want to try do. And that's very cool. What have we done? But how do we actually make this work in the real world? It's all good and well that we can all, in 5 minutes have a Twitter bot that talks like Donald Trump. Artificial dumb, we like to call it. But that's not really a business use case that we can do anything with. There's a reason people aren't talking about it, because the problems that you kind of have in research don't often translate into industry, particularly if you're working in kind of a very academic environment. If you look at it when you're talking maintenance, that's slightly less of a concern if you're just doing a thesis. You'll probably do some stuff, release it. Might be a bit more if you're working on something like, I don't know, a open source project, a big one, TensorFlow, then you'll get some community support. But if you're working in industry, people's lives might depend on this system for the next 20 years. So maintenance and maintaining models, fixing the leaks and the plumbing become really important. Your team size are usually a lot smaller in research. I mean, these days they are bigger. They're probably 12, but I said 1 to 20 in industry, but I've seen industry teams that go to 50 people, split up into little sub-teams. And that introduces a whole bunch of other issues. In research, if it solves the problem, awesome. That's really cool. We made progress as a species. In industry, if it doesn't solve the problem, they don't pay you for anything, so it kind of has to solve the problem. Ethics in research is obviously very interesting and very relevant, but it's actually required, and you should be taking ethical considerations if you're doing anything in industry. So where does that leave us? We have all these things. We're clearly doing really well on the technology front, but there's a whole bunch of stuff that we haven't really looked at. So I'm going to talk a bit about ops, a bit about the engineering, a bit about ethics, and I am not going to do ethics justice. One day I will do a good 2-hour-long talk. Thankfully, this is the ethics room. We have a whole bunch of amazing speakers that will be talking about ethics. I'm going to talk about interpretability. I'm going to mention causality, because it's currently my favorite thing in the whole world, and a little bit on uncertainty. So this is our really dumb diagram. It's a pretty dumb diagram, but this is kind of a summary of what we all know happens. There's some data, you pick an algorithm, you work on that code, if you're coding it, and output some sort of model. That model you can analyze the results of how well it did, and then you can also deploy it to production. And all these things kind of connect and feed back to each other. And that's my overly simplified diagram. It leaves out all the details and hopefully is a little bit useful. And what you can see is clear there. You've got these lines going back and forth. Humble iteration. Nando de Vries said at the Indaba last year. It's simply humble iteration. That's how we get these things right, is we do it over and over and over. So we started with a model that's bad, and the more time you spend on it, the better it'll become. So we should build our processes in that same vein. So let's talk about data. So I made these dumb drawings. That's the data pad. You should love him. He was very expensive to collect. You should definitely look after him. It's also very painful. We should watch out. You probably shouldn't do this. And I see this quite often. It's like, oh, it's a CSV. And if you learn online in particular, they kind of just, everything's a CSV. Isn't that nice? It should never just be a CSV. If it is a CSV, it should be backed up in at least like 3 places in a cloud. Should probably do something a little bit better. If it's not too big, so if you're not dealing with terabytes of it, then try version it. What? Oh, there you go. Hold on. I think it's because I keep standing on the cord. Cool. If it's not too important, try version it where possible. Have a well-tested data pipeline. So what that means is your data coming in, obviously there are probably transformations that get applied, there's probably some cleaning that happens, and if you've got data continuously coming in, that should be really well-tested and robust. And if it's small enough, put it in a database, at least, if you can't version it. What's interesting about versioning is we think about, if you come from a software engineer, actually, let's do this in the room. Who comes from a computer science background? Hands up. Who's from a stats background? Who's from a kind of applied mathematics background? And who's from somewhere else? There are a lot. Well, who do we have in the audience? Some engineers? Engineers? Any biology people? Neuroscience. Doctor, medical doctor over there. If we're talking code, if you probably know GitHub by now, even if you're not that well versed in the software world, and you put your code there, and we always put our code there. So data version control, that's a thing. I had to look it up because we had this problem, right, where we had loads of data, well, not loads, medium-sized data, but it was very valuable. We spent a lot of money on this data, and if it kind of the distribution shifted in any way when we added new things, or if we changed something, or if you had a really bad mechanical Turk run, which is something that happens very regularly, you suddenly have to take that data away. And if you didn't know what state it was in yesterday, then you've got to do this fight. And if you're regularly iterating, like in the same way software does in an agile process, 2 weeks, you're getting data in, you're training it, you're releasing a model, then knowing exactly what your data was a day ago is really important. So they have all these great tools. Won't go into them too much, but one's called data version control. There's another one called Kilt, and this picture over here is Git large file storage, which is actually the one we chose to use. And there you can actually download a couple of extra scripts and a couple of extra tools to actually do sort of divs on your data. They're all a little bit clumsy, but they are certainly better than not having it at all. For each pattern, always make sure you store its birth certificate. It's having a birthday. You need to store its source, so where you got it from, because different experts might have different impact. You need to know the status. Is it new? Is it something is irrelevant? And most importantly, you have to store your date, because data changes over time. You might want to start expiring data that's no longer relevant to your current user base. Bad data is reality. It's inconsistent, it's incorrect, and it's certainly not representative all the time. But that's all you got. And I think we were resonating a little bit with this earlier, which we should stop using models that would need perfect data. On the other hand, you can also say, well, I've only got bad data, what can I do with it so far? So let's improve it over time. So let's track it and see if we can get it better. So let's take humble iteration, not just to the whole process. You keep laughing at it. Take it not just to the whole process, but let's think about each aspect, including our data. Who's heard of continuous integration? And no, it's not a math term. I was actually explaining this to someone, and I had to be like, wait. They were like, what about discrete integration? And I was like, no. Continuous integration is this scenario. You have laptop, you might have code, you might have written tests, or you've got a person running tests, you push to GitHub, and then it gets deployed somewhere. And that's cool. And then that happens, inevitably, every single time. And it's always this excuse. Every single time it worked on my machine. So the idea with continuous integration is you push to GitHub, and then it triggers off some tools. And those tools actually go kind of build your environment, run some tests, verify that everything works, and then we push that to the cloud. So you know your code's going to work. But we were talking about data. Yeah, that's what happens. If your continuous integration tool fails, you can't deploy your code, and you have to fix it. Nice checks and balances. And I said, well, why, if we're working with these small to medium-sized data sets, which often we are, is there a way that we can maybe do that? Is it valuable to do that for our data sets? Should we be writing unit tests and be running continuous integration for our data sets? If you're working on these big teams, you've probably got maybe 20 people playing with it, transforming it, collecting it, working on it. Is it valuable to do that? So we actually did put it in. We said, cool, let's validate some of our types. Let's check for things that are actually duplicates. Let's check our distributions are correct, that we haven't swung unnecessarily into some realm we don't know. Now, we can't obviously test every single aspect of the data, but just having these kind of basic canary checks prevents stupid things happening. Stupid things like, I mean, it's a CSV file, you change your line endings, or you change something stupid, and suddenly your model doesn't process it. So it's really important to have. Let's talk about training quickly. Training is very boring. It's actually solved. We have so many tools to train stuff. Once again, it's code. Version it, treat it that way. Have continuous integration. Unit test it as far as possible. Architecture choice. Architecture's hard. I once got this advice, which was overset your data, well, your problem completely. That way you know your model has the capacity to learn everything you have. And from there, add regularization and start minimizing your models. If you don't want to do that, you can get a bunch of hyperparameter searches or architecture searches. Google's AutoML, they actually just had a really interesting competition, I haven't seen the result yet, where they put AutoML against a bunch of Kagglers, and it's a Kaggle competition, and last I saw, AutoML was winning. So it accurately evolved an architecture that would be able to solve the problem. This is really interesting. So sometimes you'll have a problem with your users, so users will start freaking out, and that makes clients freak out and investors freak out. And they come back and they go, what went wrong? The model isn't performing, your metrics are better, what happened? And you have to be able to be like, this model ties to this version of the code, which tied to this version of the data. Because you can't always answer that question. If you're not tracking and committing them all together or have some sort of way of drilling all the way down, you're going to have this problem. So we did it with like a database and Git tags, but you could essentially just commit everything together and be very useful like that, so that when you know something's running in production or you've got 12 different models and something goes wrong on one of them, you can literally tie it back to which code generated, and you can actually go fix that. Sometimes there's a bit of a cycle between the code you're writing and what actually ends up in production. There's like a couple of months. So by then your data's changed, the data you're playing with, and the model in production's freaking out. And you can't remember what the problem was. Maybe you've solved it already. Maybe you've made it worse. You don't know. Particularly useful when you're dealing with users who change their behavior all the time. So let's talk about our models. This is a model. He's like a potato with a monocle. I'm not sure why. I thought he was cute. Model is a configuration. You can version a configuration. You can store it in a cloud-based place. It's cool if you can get it technology independent. These days there are nice formats where you can store that because the place you're training is not necessarily the place you're deploying. Sometimes you're deploying to a phone, sometimes you're deploying to a giant cloud of GPUs, very rarely because no one can afford it, but yes. So make sure you look after the model a little bit. When is it good enough? When is it good enough? And in research you just go, look, it got better. And you publish it, you go, look, we made it better. Okay, it's better than whatever was there before. And that's a little bit different in industry. And industry is like when your model's going to add value to the user, then that's good enough to deploy. I mean, there are some caveats. If you're in health, you need to be careful. Because if you start deploying models, that could actually mess with people's psychology if it gets wrong and how they change their entire life to fit something that was incorrect. So there, I think we move with caution. But in general, if you're kind of in line of business sort of ML, just make sure it's adding value to the user. The idea is sooner is better, because then you can learn about your users a bit better. And once again, humble iteration. So that was a model. Let's talk about analysis. So analysis, when you're doing research, you don't always go do this, because you just you have an idea, you try it, like some hypothesis, you test it, you run it, you see if it good or bad, and sometimes you do a bit of analysis specific to your case, but you don't have to go into much detail necessarily. In industry, there are lots of questions. Their clients, they have many questions. Many, many, many questions. They're paying you lots of money, so they need the answers to their questions. They want to know how it's doing, why it's doing it, how can we trust it, you know? So your whole variety. You can do some performance analysis, which is just, you know, your standard metrics. Data analysis, so exploratory data, understanding what your data is. Error analysis, so looking at each of your areas and trying to classify them and figure out why you were getting errors on those things. Kind of interpretability, so you can check, you know, that the model's actually using useful information, and certainty. I'm going to get into a few of those. So start with performance metrics, because we're going to do performance. If you're working with businesses, make sure they understand your metrics. So if you're using area under the curve or whatever it might be, make sure they understand what that means and the implications and how they can use that metric to make business decisions. If you don't, they're going to end up at a place where they're like, how do I know this one's good? And you have to sit down and explain it. They might not accept your explanation. So always say, try to get them to understand. A lot of the performance metrics aren't that hard to understand. Have one number that tells you how good your model is. There's no point having the 5 metrics we always track. They don't care. The user doesn't care. You can't use five different numbers to compare 5 different models, and how do you combine them? How do you know which one's actually better? So pick one, and you can change that one over time. So if you've got some end user that, you know, your your model that, your app that takes photos of cats, tells you which cat it is, starts classifying porn as cats, then you need to add a big penalty. And from that point onwards, your metric might be your area under the curve plus a penalty for behaving incorrectly. I don't know where our picture went. We had a picture of a cat in a bikini, so we thought that was appropriate. I don't know where it's gone. Well, very inappropriate, I'm unsure. So error analysis, very stupid. Oh, there it is. I put it on the wrong slide. Surprise cat. Error analysis is simply looking at exactly what example got misclassified, and I suppose, you know, that would be an all right one if it did misclassify. And this is really small and very stupid, and this is all those kind of data patterns that we've got, NLP problem, like I said. And here's kind of classification errors and what the prediction should be, and right at the end we've analyzed, and there's no way around it. You have to sit and go analyze 100 patterns or so, at least. You can get through them pretty quickly, and you go, look, what are our problem areas? And they usually point to problems in your data. It's usually, oh, our user base has shifted, and now we've got a lot more designers, and our data is not actually reflecting that in some way. So that's one good thing. You've got your dev set, so, you know, split into test, train, and dev. And your dev set, you should be kind of growing over time, because that's one of the descriptors of your problem. Gathering outliers that break your model, sampling extra production data, getting those like manually labeled by the people who are the experts at the problem, and using kind of well-known contrived examples as well. So the idea is you're growing your data sets, and you're growing your understanding of a problem space. And in an industry, you very rarely have a full understanding of what the problem space is. I kind of, you know, you've got a list of problems, you don't know which one to work on. You know, the model's got 30,000 problems, what's wrong? And what should you work on next? You have to address some of them. So I kind of took this approach of saying, cool, what is the impact to all of my users? What is this problem impact? If it's only impacting one user badly, maybe that's not a big issue. But let's say you get a 60% classification error on a certain type of problem or certain type of use case, and it happens to be affecting 80% of your user base. It's far more beneficial for you to work on that, which is only, you know, it's subpar, it's sort of working okay, than working on the really big error that's only affecting one guy. And I got an extra characteristic earlier, which was you should also consider which users, because some of them have investor checks. So that might pump up your value of the importance. And what's cool is if you kind of track the performance of these problems over time. So by problem, I mean, for instance, on ours, we had an issue classifying, I don't know, text that had something to do with DevOps, which is a dev term that isn't in most dictionaries. Well, old ones. And so then the idea is that each of these could be a problem, and you can kind of just have some sort of metric and indication of how they're performing over time. And this just gives you a better detailed analysis to show client. And client says, you've got a new model, has it solved problem X? Now usually you'd be like, oh, well, my AUC got better. Or like, my MSC got lower, not Did it improve at classifying cats? Whereas this, you can go, yeah, it got better at classifying cats, but it has gotten a little bit worse for some reason on classifying dogs. Is that okay? And that gives them the power to be like, yes, this is fine. This is cats is a worse problem right now. So yeah, you can do this. You can track these problems over time. You can get an interface where we can start extracting them from users. You can start manually adding test cases and bolstering your dev set or your test set over time. So, neural networks are black boxes. Yes, we know that. We want to do some interpretability stuff. So, I don't know if anyone's heard this story. Yeah, I think most people have. The story where they were trying to train a classifier to classify wolves versus dogs. And they got like a really high accuracy. And then one day they realized it was classifying the snow. Good job, team. And this picture is generated from a tool called Lime. There are a whole bunch of them. This one's also Lime. This is saying, cool, this part of the picture adds to the cat classification. This is why we're thinking about not classifying it as a cat. And this is really great because it's very visual. So you can show something like this to a client and an investor, and immediately you get their trust. Certainty, so this is something Stuart actually presented a couple of years ago at the Indaba last year, and I found very useful. And the idea is, if you're using neural networks, because that's my background, using neural networks, we're not using Bayesian techniques, so being able to estimate uncertainty is kind of strange. So a couple of ways you can do this. One of them is do dropout at inference, if you know dropout, and that what you do is you resample from the same model a couple of times, and then you can plot a distribution. And then you can use that to kind of gauge how uncertain your model is, which is very cool. You can add probabilistic layers, which is a much harder approach, because I'm really terrible at probability. You can also add layers of noise to do the same thing. Automation. Stupid stuff about automation. Automate as much of your analysis as possible. Make sure you've got graphs that are generated. Do canary checks, which are basically the 5 things in your problem that have to pass. If they don't, something's gone very wrong. And if you're iterating really fast, sometimes those 5 things do fail. You'll have completely done something wrong on your data, and suddenly your 5 canary tests will fail. Canary test comes from, they used to have canaries in the mine, so when the oxygen went low, the canary would stop singing or pass out or die, I'm not sure. And then they'd know that they had to evacuate. But with this thing, I'm really, really into this. Like, if you've come from a data science background, you love your notebooks. You're like, yes, I can run things, I can have pictures, it's amazing. And the problem is I can't deploy a notebook. So Amazon tries to do this, which is cool. So you can do that, but that's also really bad because you don't run tests. You don't write tests on your notebooks. So cool, play in your notebooks. Have as many things as you want. I call it notebook hell when you've got so many notebooks you can't remember where you put what, and for some reason it's easier to find it in well-documented code. Can't peer review changes, so if I change something, I can't do a nice git pull request that's going to highlight what changed in the code. I can't write proper unit tests, and it ends up becoming monolithic. So you end up with these giant notebooks that no one ever looked at, and now you have to go fight through them. Very bad if you're trying to pass on those projects, so just be very careful. Cool, production. Production these days is easy, except for these things. When we're building our models, we always forget. This is Docker, if you've ever heard of Docker, and the little models in Docker. It's quite cute. And there's a Docker swarm. Anyway, I have to explain my terrible diagrams to you. The thing that people forget about, we think, oh, let's get the accuracy really high. And that's all good and well, but it doesn't help anyone. If suddenly the model doesn't scale, it's not fast enough, it's too big to run on certain devices, and this happens all the time. This is a story that I think Stefan told us at the Indaba 2 years ago. And that's Wavenet, and Wavenet is the thing that powers the voice generation. So, or text-to-speech rather, on your Google phones. It was iconic, this algorithm. But there was a big problem. So I think Google AI or DeepMind invented it. And they passed it off to the engineers. And the engineers were like, we can't use it, it's too slow. Sorry, we can't. And they had to go through another 8 months of an expert team that had been put together with engineers and research scientists to just try and get this thing to be fast enough to actually run in kind of a more real-time environment. And I don't know about you, it actually is still slower. So if I notice the speed of it compared to maybe 5 years ago, sure, it was a worse voice, text-to-speech, but it has actually slowed down. And their solution was actually take a less good model, so they actually had to make it less accurate, and that's how they got it in. And you can leave it to the crowd. They all have amazing tools now. Google's got entire infrastructure just based on automating TensorFlow. So TFX is an entire end-to-end system. I haven't used it yet. I heard people are saying great things. Azure's got a machine learning environment. Amazon's got SageMaker. Also heard is quite good. They're all reasonably expensive. Based on cost, Google's going to be cheaper if any of you are interested in going into it. They also give you the most credits. Cool. That's our oversimplified diagram. There's work to be done. So we've done a bit of ops, a bit of engineering. We've talked a bit about interpretability, uncertainty, and the things that aren't going to cover are ethics and causality. So ethics, I'll let people I'll let other people do it justice, because it actually requires hours, days, workshops on getting that right, because that's probably the most important thing, and I've completely left it out. And causality is also really important, because without this, we can't get ethics right either. Cool, so here's a couple of important resources. Go check out Stewart's and Emoju's talk for ML in production. Julie Evans got quite a nice little cute post, Machine Learning Isn't Kaggle Competitions. And then Andrew Ng, I've got mixed feelings about Andrew Ng, but this was actually really good. Yeah. Machine Learning Yearning is a fantastic, fantastic resource if you want to start doing these things in production. So there we go. I hope I haven't gone over time. Thank you.
I'm an AI developer and smart contract technology solution. My question is that you develop machine learning models. You deploy a RESTful API.
I don't. Well, sometimes I do.
Yes. So for it to be deployed on our cell phones, maybe let me give you a scenario. Suppose a bank wants to deploy a self-banking system. So it has to be fast. So you have to take your model into cloud, because if it runs locally, it affects the runtime. So where does it lead our IT team?
Where does it lead?
Yes, because now it's self-service and then it's on cloud. So it's always live. So where does it lead our IT team? Do we still need an IT team?
Do you mean an internal IT team that only deals with
Yes, in technology, yes. Except when we do cyber technology.
So yeah, in-house IT teams should be, if they're not learning how to be support and doing kind of cloud management services, they're probably going to lose their job. Except the banks exist, so they won't for a while.
From your experience, would you say actually like decoupling an AI solution such that obviously if you are deploying it to a client side, you have the dependency on their own infrastructure and their own setup, and then when you actually develop an ML solution, probably most of the time you will be making use of like external resources, cloud resources, and so forth. So in terms of now rolling those solutions into the client side of the equation, would you find that from a cost perspective, in the long run, is it more costly for a client to embed this solution internally?
Yes.
And then keep them? But there's that issue of now, if you rely on an external environment, now the sovereignty of your data and your own infrastructure becomes compromised. So in terms of the challenge of both scenarios, which would you say have worked more efficiently in the long term?
So you're worried about privacy?
Yeah, but privacy, and in terms of like just having control over the data that you create for maybe your clients or your customers.
Okay, so having control in terms of having control for your okay, so in terms of that, okay, so the trick is to select the right cloud provider. So for instance, Microsoft actually has SLAs, which make certain guarantees about your data. I don't think either of the other two do, or the two big players. But the trick is partner with the right cloud who can actually get you the right solution. I can tell you from much experience, and I actually love using Google, but if you're going for that route, the best people to partner with are Microsoft. And there are a couple of other really great things. So people are, if you have a local data center, so let's say you're working in a bank or working with a bank and they've got their own data center, there are these really interesting things where you can actually deploy kind of an Azure system or a Google-like system. I think they talked about it like a week ago. You can actually deploy them on your own data centers, and they can speak really easily with other cloud-based services. So then you could keep your kind of private data locally. So that's often it. So there's always a piece of sensitive data that you keep local. And then you you keep the less sensitive stuff or the anonymized stuff in the cloud. And making that pipeline as seamless as possible can be quite useful.
I have an interesting question. Well, I think it's interesting. Because you manage like a machine learning team at Retro Rabbit, and you're developing products for real users using machine learning models, and in my experience that's a hell of a lot more uncertain than traditional software engineering, where you can generally write down your requirements and you know that if you estimate how long it will take and you times by 3, you get a good runtime. But like some machine learning problems, it's like, oh yeah, that should be simple, and then you end up spending 6 months on it and it's like super hard. So have you guys adopted any changes to your Agile or Scrum processes that you use at Retro Rabbit that help you get a better
hit rate on that? So we were very bad at it for a very long time. And some of it, yeah, I don't know anybody's good. If anyone's figured out, let me know as well. But so there were a couple of things we did that helped. So the first thing was our client, he's smart enough to understand that this is a research type operation, and he classified it in his brain under R&D. And that's, well, already when he did that, I was like, that's why he's less strict with us on certain things. At the same time, the other thing we try to do is you'd kind of try balance your things that are easy to estimate with these stretch goal tickets that you're like, well, what you end up doing is these big tickets that you don't know how long they're going to take, time box it. So say, cool, I'm going to work on this. It's really uncertain, or we're not sure, or even if you are a little bit certain and you haven't done it in a while, you still say you're uncertain. And you say, cool, well, I'm going to dedicate a day to this in my sprint, and however far I get is however far I get. And that they can usually play with that. They can say, yes, this problem is this important to me or this important to me. If it's this important, then they must just work on it all your time until you get it done. And if it's this important that he kind of wants to have some movement on it, then he'll be like, okay, yeah, take Monday and just do that, and then continue with the rest of your tickets. So time boxing helped quite a lot in that regard, but still really bad at it.